Okay, 10.2 focuses on population proportion, the hypothesis test for population proportion. If you've not already watched the stats hypothesis testing p-value method video, please do that before you continue with these notes, because there are things that I am not going to explain because I think he does a really good job at doing it, and I'm not going to try and re-explain something better than him because I like that video. The end result of that video comes down to deciding whether to reject the null hypothesis or not reject the null hypothesis. And so you reject the null hypothesis if the p-value is less than the level of significance. And you do not reject the null hypothesis if the p-value is greater than the level of significance. So we'll use our calculator to find the p-value. We've got the whole list of steps there, and we'll talk about that. And then you're given alpha, you're given the level of significance, and then you're comparing, and your ultimate decision is, am I rejecting the null hypothesis or not? So when I look at example 1, it says test the hypothesis, state the conclusion. So I am going to move that over a little bit. I'm going to go to stat. Then I'm going to go over to tests. Then I'm going to go down to one proportion z-test. For me, it's number 5, and hit enter. And then I'm going to input everything that they give me. So p sub 0, what I have typed here is that p sub 0 is the proportion given in the null hypothesis. So since the null hypothesis is that p equals 0.3, I'm going to write 0.3, or just 0.3. X is 75. And n is 200. And then because the alternative hypothesis is that p is greater than 0.3, I'm going to highlight that it's greater than 0.3. And it actually doesn't matter if you hit calculate or draw, you're going to arrive at the same conclusion. I like draw because it kind of visualizes what's going on here. It relates it back to the z-test and the normal distribution that we're really not going to focus too much on in this section, but it shows you that they are connected. So what I want to get out of this is p. So p is equal to 0.0103. And so I am comparing p to alpha. So the p-value is 0.0103, and alpha is 0.05. So is this less than or greater than? Well, alpha is about 5%, p is about 1%, so it's less than. So because p is less than alpha, I reject the null. So I'm going to reject the null hypothesis because the p-value is less than alpha. So go ahead and, I didn't input the information for the practice problem, so we're just going to skip the practice problem. But that's really what it comes down to. You type it in, you get your answer. And then you also, so we're skipping this, I didn't type anything. And then we're going to ultimately need to interpret it in the context of a word problem. So reject the null hypothesis means to accept the claim of the alternative hypothesis. So if this previous example was the percentage of teachers that have returned to school during the stay-at-home order to get stuff or to work on stuff at school, whatever. And so I say that it's 30% of teachers. And you go, Miss Barrett, I think it's more than 30%. That's my alternative hypothesis. And so if I survey 200 people, 200 teachers, and find that 75% of them have gone back to school, I perform this math here, and I ultimately reject the null hypothesis, which means to accept the claim of the alternative hypothesis, which would be to accept that greater than 30% of teachers are returning to school. If I was told to not reject the null hypothesis, it means that there is not enough evidence to accept the claim of the alternative hypothesis. So there is not enough evidence to accept the claim that more than 30% of teachers have gone back to school. So number 2, an official with the Illinois State, actually pause the video, read the problem, unpause the video. Okay, so we are going to input all the data that we have, find our conclusion, and then ultimately interpret it. So I'm going to go to stat. I'm going to go to tests. I'm going to go to one proportion z-test. So I've got the proportion from my null hypothesis is 0.5. X is the like number of successes. So the fact that 219 out of 500, I'm going to put that X is 219 and N is 500, my sample size. And then let's read the problem here and decide. So they say, does this represent significant evidence that less than half? So I'm going to go to less than. So the fact that I'm using 0.5 in my null and alternative hypotheses is because they're talking about less than half of Illinois students being prepared. So I'm going to use 0.5 and I'm going to say less than. And whether I hit calculate or draw, it gets me the same conclusion. My ultimate goal is to find this p-value, not p-hat, but the p-value, which it looks like 0.0028 ultimately. So my p-value is 0.0028. Compare that to alpha. So I'm comparing that to alpha. So since the p-value is less than alpha, do you remember without having to scroll up? Because it's less, I am going to reject H sub 0. If P is low, reject the null hypothesis. So I'm going to reject the null hypothesis. And I'm going to interpret it without writing anything down. It goes back to rejecting the null hypothesis means to accept the claim of the alternative hypothesis. So the alternative hypothesis is the claim that less than 50% of students are ready for college math. So because I ran my test and I'm rejecting the null hypothesis, because I'm rejecting the null hypothesis, I accept the claim of the alternative hypothesis. So I accept that the proportion of students that are not ready for college is less than 50% or less than half.